The next part that we will be starting is AWS networking part 3. So let's go with that. What we'll be covering for this one is security groups, NACL or Network Access Control List, VPC Route Table, Autoscaling groups, application load, and application load balancer, right? So again, if you're new to this concept, to these concepts, it's still okay. You will get a bigger idea of what it is. If you have some previous understanding, it's even better, right? Okay, let's go with this. So this is where we left off from the previous part. Now I'm getting rid of all the area ranges, now coming back to this region with a specific VPC, right? So adding some more, I would say, EC2 instances into this public subnet, and then also giving some, since they're in public subnet, they will have a public IP address, but if they're in private subnet, then they will have private IP addresses. Now we're coming to the concept of a security group, right? So again, if you take this an example of your, I would say, your castle, right? So this means then this will be, this is your ward, this is your chamber, and then this is a room inside the chamber. If you want to take the example of your house, or maybe like a company, you can say, so this is the entire big company, then this is a specific department, and within that department, there is an office, right? So the people sitting inside the office are actually EC2 instances in the security group, which is a security wall. Around this EC2 instance is actually a room or an office, right? Okay, so I'm adding an EC2 instance in here too, and then we can consider this, yeah, as a secret room. I wouldn't call it like a secret room, but the thing is, again, even if they are being in a public chamber, right? No one from the outside can reach out to them if the ports on the security group or the port on the security layer or security wall allow for that, right? So even being in a public chamber or public subnet, if the route on the security group or the port on the security group doesn't allow for the traffic, they cannot be reached out. So that's what it is. Okay, so now, and then we have the network access control list. So the security group was at the level of the EC2 instance, but the NACL or the network access control list is at the subnet level. So if you can see this purple dashed line or a rectangular kind of like wall around the subnets, that's where the subnet work. For example, any traffic that wanted to reach out to this subnet, they first have to go through the security of the NACL, and then they have to go through the security of the security group, and then they have to go through the EC2 instance. For example, if any of the traffic is banned at the NACL level, it cannot reach out to the security group. And then even if it reach out to the security group and then it's banned at the level of security group, the EC2 instance cannot have access to that either. So that's how it works, right? So the same goes, that can be like a chamber wall or a security wall around this public chamber, inside which we have our secret or secure room. Right, so I think so I misspelled it before. It's actually a secure room rather than a secret room. So it's a secure room. Okay. Yeah, so here you can go. So traffic coming from the internet first have to go through the NACL, and then it has to go through the security group, and then it reach out to the EC2 instance in there. Next up, we are going to be talking about the route table, right? So route tables, consider them as like registers that has the information about the different traffic in and out, right? So anything inside wanted to reach out to the internet, what they do. Anyone from the outside, they wanted to reach out inside here, how do they do? So it's kind of like a routing information for that, right? And then, yes, it's a route registry. For example, if you go through the castle analogy, So anything that's meant for this VPC, which is kind of like the phone number for this VPC, it's kind of local, right? So anyone inside this castle, they can talk to each other, and anyone inside this VPC, they can reach out to. So for example, if their destination is this, it's local, means anyone talk with each other. If the destination is kind of like 0.00/0, which means internet outside, it goes through the internet gateway. And then, for example, if it's 10.0.2.1, right? So let's see, where do we get that? And I said it's through the bastion host, right? So this is our web server. So any traffic, say, that's coming from the outside and it's meant for this web server, in the web server being in the public subnet, in the private subnet, my apologies, it means they cannot be reached out directly, so they have to go through the bastion host. So it's me sitting outside and I wanted to reach out to this web server, right? What I do, I go to this route registry, and then I look into where I'm going. Oh, I have to go through the bastion host. Okay, then first I go through the bastion host, I ask for their permission. If they're going to allow me, then I'm going to reach out to the web server in this private subnet. So this is how a route table works. So actually, whenever the internet comes through the internet gateway and then it reaches out a router, then a router has a route table. So the route thing will come up later, but from the internet gateway into the router, in a router has a route table. And the route table has the information about the different routes. How do we kind of direct the different traffics coming in and out. Okay, so I think so that was the concept of the route tables, right? So now I added an autoscaling. Again, if you're new to the concept of autoscaling, it means this, right? So you have one worker. So I call the EC2 instance or the compute service as a worker, sitting out there doing some stuff, right? So if the workload increases, right? So what do? You have to manually spin up another EC2 instance, or you have to manually start or deploy another EC2 instance. But if you're using autoscaling, they can detect the workload. If the workload is more, they can spin up more EC2 instances, or they can deploy more EC2 instances in this public subnet. If the workload is low, then they can shut down some of the EC2 instances, then you will have fewer. If workload is more, for example, you can have 4 more EC2 instances. This autoscaling will do that automatically. But if the workload is lower, they can come back to the one, right? So then you can have a specific number. For example, my CPU utilization, if my CPU utilization is 50%, add 2 more instances, then we will have 3 instances in here. But if my CPU utilization is, say, 80%, then spin up, I would say maybe like 5 more instances, and there we will have 6 instances in total, right? And then by CPU utilization, mean the CPU utilization of each specific, I would say this EC2, for example, this EC2 is working, CPU utilization reach 50%, this means you add 2 more instances. CPU utilization for this EC2 instance reach 80%, then you kind of put 5 more, then you have 6 in total. EC2 instances. So this is how autoscaling works. Again, I will be talking about this concept later on when we talk about the compute services. But for now, this is how it works. Okay, so now we talk about, we added the application load balancer. So now if the traffic is coming from the outside, right, and you wanted to load balance it between kind of EC2 instances in this subnet and also the EC2 instances in another subnet, right? In another availability. So you have one availability zone and a subnet in here, then you have another availability zone and a subnet here. And if you wanted to load balance that traffic, then you're going to be using application load balance, right? So we have different, so they're actually, the main concept is, I would say, the elastic load balancer, right? And then within the elastic load balancer, you have 3 different types. So one is application load balancer. The other one is network load balancer. And then we have classic load balancer, which is an older version of it. And I'm probably thinking they might not be in use anymore, or kind of companies would not want to use it because they have the newer versions in better versions, why they would go with a classic load balancer. And then they also have a gateway load balancer. So 4 in total, so I see 3, but like the gateway load balancer was added later on. So we have application load balancer, network load balancer, gateway load balancer, and then we had classic load balancer, right? So classic load balancer might not be used anymore, but now what each one of them do, we will be talking about them in a separate video. But at the moment, just consider they're kind of load balancing the traffic to different workers or to different EC2 instances in this case, right? Okay. So that's, I think so. Now let's see what happens next, right? So the traffic is coming from the internet into the application load balancer and then coming to this EC2 instance and then also dividing into this one. So I say I want to send 50% of the traffic here, 50% here. This is how it works. Okay, so I think so we almost finished this part. So our next part will be part 4. So I hope it kind of made sense up to this point, right? So we talked about, I would say, the security groups at the level of EC2 instance, network access controllers at the level of a subnet. And then we talk about the autoscaling group. We talk about the kind of increase or decrease the number of EC2 instances based on the workload, and we talk about the application load balancers, which divide the traffic onto different EC2 instances based on the percentage that we define. Maybe like I want to send 20% here and 80% here, that can work out as well. So that's it.